page 3 of the scheduling notes and section 2. So I'm going to introduce you to the RTOS for our course, and the title for this section is a bit of a mouthful. It's the SimSys RTOS version 2 with RTX 5. So RTOS 2, let's call it that, is an API, and that stands for Application Programming Interface, and it's how you interact with something. So it defines the functions and behavior. And then we have RTX 5. So RTOS 2 is like a standard. RTX 5 is a kernel, and it implements the RTOS 2 API. And so RTX 5 stands for Real-Time Executive version 5. So RTX 5. And so with Microvision 4 we had RTX 4, and with Microvision 5 they updated it to version 5. It is a kernel, an RTOS kernel. So what it does is it performs scheduling, and it provides other OS services. Such as communication between tasks and that kind of stuff. So we're going to look at an example now, a real example that you can compile and run on the simulator. This example has 2 tasks. I've simplified it a bit. It's big enough as it is. And so task 1 has normal priority, and it's going to wait for the button push, and then it'll just print something out. Then we've got T2, which is low priority, and it is going to flash an LED on and off at about 1 Hertz. So here is our flow diagram now. We've got the RTX 5 scheduler, and it's this kind of thing, and it's going to periodically tell task 1 to run. So task 1 has an entry point, and the first thing task 1 is going to do is it's going to wait for let's say the button to be pressed. So somehow going to stop its execution until it happens, and then it's going to print a message to the console, to UART1, and it does this in an infinite loop. And you're going to see that all of my tasks with an RTOS are infinite loops. So I'm going to have a dotted line from the scheduler to T1. Sometimes it will decide that T1 should run. And T1 has normal priority. And then we've got task 2, which will also sometimes be told by the scheduler to run when it decides that it should. And it is low priority. And so it's got an entry point, and what it does is it's going to turn the LED on, and then it's going to have a bit of a busy loop. I'm not going to show this in the flow diagram, it'll just complicate it, but it'll waste a bit of time, and then it will turn the LED off and repeat. So it'll act kind of like a heartbeat, I guess, or a pulse for our application. And then finally we have the push button ISR like before. So it will clear the IRQ. Maybe I should have put that in the previous flow diagram. And then it is going to set an event flag, and this is actually what T1 is waiting for, and that's the whole of the ISR. And so the push button ISR sort of runs, it runs independently of the scheduler, but when it runs, by setting that event flag, that then enables T1 to be run whenever the scheduler thinks it should next run.